The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to one more webinar in our AMS webinar series. My name is Joe Anand, and I'm the product manager here at MecSoft. I will be joined today by Uday Honalagare, who's our support manager, and he will actually be running the webinar. I'll be in the background monitoring any questions that you might have and answer them during the webinar. Before we get started, though, for people who are joining us for the first time, there's some housekeeping tips that we would like to go over. The recording of this webinar will be made available to all the registrants. After, we'll give us a couple of days to clean it up, clean the video up, and then we'll send it out to all the people who have registered. And then we typically reserve last 10 minutes for questions, but also we want to make this as interactive as possible. So if you have any questions during the webinar on anything that Uday is going through, you can use your chat window for questions. The chat and the big red arrow is pointing to the chat window that you should have on your screen. So just type in your questions. I'll be in the background monitoring them, and we'll hope to answer as many questions as possible. And if we can't get to any of those, we'll definitely send you email with any responses. Regarding the topic of the webinar, we kind of decided to do something a little bit different on this webinar. And based on the response we got, seems like this is a very popular topic. The title of our webinar today is the most requested support items in CAM. This is based on our support team's, culling of all the different questions we get, and we came up with these list of topics that we would like to go over today. I think the most often or most confusing aspect to users, or especially new users who are using our CAM system, is the understanding of the location of cut geometry in two-axis operations. We have quite a bit of control on that, and Uday is going to be showing different ways of moving the cut geometry to get the desired results in your cutting operations. And then also, how do you control cut depth for different cut levels? Aligning stock to part, that's also a number one, a big item that people ask us about. And then establishing work zero. And then finally, specifying cut start side and 2.5 axis operations. That's also a big item that we frequently get questions on. So, and as I mentioned, please feel free to ask us any questions during the webinar, and we'll get to it as soon as possible. And so, without any further delay, Uday, please go ahead.
Thank you, Joe. Hello, everyone. Thank you for joining us today for this month's AMS webinar series. And as Joe pointed out earlier, we will be covering several different topics today that are commonly asked about during our support calls or emails from our users. And we'll try to do our best to cover these topics and answer the questions for you. And feel free to ask any questions as we go along the webinar today. I will be covering most of these in Visual CAD CAM and Rhino CAM, so the workflows would be very similar if you're running Visual CAM inside of SolidWorks or using our CAM for a Libre, which is a Libre CAM. So the concepts, the terminologies we're going to be talking about is going to be exactly the same in all our CAM systems. So without any further delay here, so I'm going to go ahead and jump into an example on understanding location of cut geometry in two-axis operations. I will go ahead and load a part that was modeled or imported into Rhinoceros, and we'll work through Rhino CAM, and then we'll take a look at a few other examples as well. Okay. So the first thing I'm going to be covering here is understanding location of cut geometry in two-axis operation and what this exactly means and how it works. So in this particular example here, I have a solid model, a prismatic part, and the stock has already been defined. I'm going to display the stock visibility in here. You can see that the part and the stock are already aligned, and you will see that the stock, there's some material thickness that needs to be faced off from the top face of the stock block. So when we go into a typical operation, which would be like a facing in this example, we will focus on our location of cut geometry here. So I'll just make a selection for a tool. And as we go into the cut levels tab, you will find location of cut geometry. So in a facing operation, a location of cut geometry refers to location where your part region for the stock is located, so you can face it down. So in this particular case, if I pick at top and I pick generate without any region selected, the system will automatically take the silhouette of the stock geometry into account to determine the part region. So when no control geometry is selected and you leave it as at top for location of cut geometry and pick generate, you'll notice that no region selected. Do you want to use the stock silhouette? I pick yes to generate. You will see that it uses the silhouette of the stock and automatically it adds one cut level right where the top face of the part is located. So when leaving it as at top, it automatically adds one cut level where the top face of the part is located. So from the top face of the stock down to the top face of the part. Now, if I would like to pick a region for the facing operation, so I'm going to clear this checkbox which says include stock model silhouette, and I'll go pick curve regions. So what I'm picking here is the top face of the part and not the top face of the stock. So if I pick generate, I'm still going to get one pass. However, if a depth is specified, since the location of cut geometry here is set to at top, you'd end up cutting deeper into your part. So for location of cut geometry for a facing operation, what we are selecting is the part region is the face where the stock needs to be. So in this particular case, you don't want to cut below the finished face of the part. So you would want to pick at bottom. And if you want to cut this in multiple steps, you can specify a total cut depth. So location of cut geometry would be at bottom as we are picking the finished face of the part. So we don't want to cut below the finished face of the part. So if you're selecting a curve region or a bunch of face edges to represent your control geometry for a facing, you would be picking at bottom. And as you generate the toolpath, you will notice that the toolpath goes to the finished face of the part. Now we'll be talking about the cut depth controls later during the webinar, but I wanted to emphasize the difference between at top versus at bottom. Now you could also be selecting using pick top. We'll go with that with an example as well. So when you set at bottom, the cut levels would not cut below the bottom face or below the Z location of where the part regions are selected. So if I give it a depth of, for example, 200 thousandths, you will notice that the final cut level will be right where the part region is located, as we've selected the cut levels as at bottom. Now, had I selected at top and generated the same toolpath, you will notice that it's going to cut further in to your part region or part geometry. So for this particular example, on a facing operation, the region what you're selecting is looking at where the stock region is located. So we want to make sure we don't cut below that. So we pick at bottom. Now, one of the ways you could also do is you can draw a sketch or a curve that represents where your stock is located. So I'm going to go into my top view, create a rectangle that represents the extents of my sketch. And now if I go to facing, rather than picking the curve region, which is at the top face of the finished part, I can pick a curve region that is located at the top face of my stock region. When I select this, it makes sense to pick the cut level location of cut geometry to be at top, meaning the region is at the top face of your stock and you want to cut down to the desired depth, which could be an 1/8 inch or a 1/4 inch or whatever the depth is, the thickness of the stock you would like to remove from the top face of the stock. So the next thing we'll take a look at is how we can establish cut levels in some of the other operation types. So I'm going to cover for a pocket operation. So we'll go into 2-axis and pocketing. We'll pick part regions. I'm going to use select curve edge regions, and I'll pick the curve that's on this top edge of this stepped pocket. So I pick the curve on the top edge of the pocket. Under cut levels, now the location of cut geometry, since I've selected the part region at the top face or the top edge of the pocket, I would select at top and specify the depth. Now, had I picked the location of geometry at the floor of the pocket, then I would pick at bottom. So in this particular case, it is at the top. I would specify a depth for it and then generate. So the Z levels are determined from the top of the pocket to the specified depth. And you can also take a look at what's called a Z level display, which is available in all operations that have Z levels, to see the Z value that's computed, which is what you would see in your posted code as well, based on where you establish your origin, you pick your location of cut geometry, and specified your depth. Now I'm going to switch to an example where you will see if there isn't a part region that can be selected either at the top or at the bottom, how do we specify location of cut geometry? So in this particular example here, you will notice that we have a chamfer on the top edge of the pocket and we have a fillet on the floor of the pocket. So when we go into a pocketing operation, I would like to go ahead and select a curve region or the part region right where the fillet, right where the chamfer ends. So I'm going to use select curve edge region. I'll pick the chain around the edge of the part. And now since this region I've chosen is neither at the top of the pocket nor at the bottom, I wouldn't be able to select at top or at bottom, or selecting at top or at bottom wouldn't give me the correct depth. So I'm going to use pick top and specify where I want the region to be or where I want the cuts to begin. So internally, the system automatically moves the Z elevation of the part region to the specified pick top. So in this case, I'm going to use pick top, and I can pick a point or snap to an end point or a near point on the model. And you can see that the pick top represents 0, since 0 being the top face of the part geometry in here. So I've specified the top. So automatically the part region is transformed or translated in the Z axis to the top face of the part. And then you can specify your depth and the other parameters in here. You can pick the depth to specify how deep you want to cut. So I could say I only want to go from the top edge down to the location where the fillet begins. So that's only 230 thousandths. Generate. So pick top allows you to choose where you want to move the region to without having to physically move the part region in the CAD. And you can control the depth once you establish your location of cut geometry. Now, while we are on this topic, I would also like to point out a location of cut geometry for for programming features like chamfers and fillets. Now, if you have a chamfer that's already built in or modeled into your part, you can go to 2-axis and chamfer operation. And for the region, what you would pick is where the chamfer ends. So I'm going to use select chain in Rhino to pick the chain of these edges. So if a chamfer is modeled in your CAD design, you would pick the bottom edge where the chamfer ends, and then under your cutting parameters, you would pick geometry at bottom. If there wasn't a chamfer modeled into your design, then you would pick at top. So going back to the previous example here, if I needed a chamfer on this particular top edge of the pocket, since there isn't a chamfer model in the design here, when I go into 2-axis and chamfer operation, I would be picking the top edge, and under cut parameters, you would pick geometry at top, and then you can specify either the height of the chamfer or the width of the chamfer, depending on how deep the chamfer needs to be cut. So if a chamfer is modeled in the part, then pick at bottom and make sure to pick the chamfer at the bottom edge of the chamfer and choose geometry at bottom. If there's no chamfer modeled, or if you're working off a 2D drawing, then you would pick at top. The same goes with 2-axis filleting operation as well. This also applies for 2-axis profiling operations. So you could pick the geometry at top or at bottom. So in this case, I would like to create a profiling operation. And if I pick the part region where the chamfer ends, I'm going to use select chain to pick a chain of these edges around the part. And since the geometry what I've selected is neither at the top nor at the bottom, under cut levels, I would pick location of geometry to be pick top. And I can use the pick option to snap to a point or an edge on the part, and then specify my depth for cutting. And then I can specify generate to create the toolpath. Now, you could have selected the bottom edge around the part in this particular example. So selecting bottom and specifying the location of cut geometry to be at bottom will ensure that the cuts will not go below the bottom level where you selected. So if you have a need to be able to go slightly below the bottom of the part by a few thousandths to relieve the material, you would want to make sure that you use the option as pick top under cut levels. You specify the start location, and then when you're in your depth, you want to make sure you specify your total depth, plus you can add the amount that you want to go past it. So for example, I could say I want to go past 50 thousandths. So when I do this, it's going to start at the top and go to the depth that you put in. In this particular case, we are going past the bottom of the part by 50 thousandths, and you can see that the Z-level display shows the final depth. So the part here in the example shown is 1/2 inch thick, and we specify to go below the bottom of the part by adding in an additional 50 thousandths. So selecting for at pick top for location of cut geometry will allow you to basically let you cut below or deeper than the thickness of the part to relieve material. Now, if you had selected at bottom, then you wouldn't be able to cut below this region unless you actually move the geometry physically in the CAD. So the location of cut geometry gives you the ability to adjust the Z-start location of your cutting without having to physically move the geometry around in your CAD system. So the next topic we will be covering here is going to be understanding cut levels in 2-axis operations. And I'll be covering that in facing, pocketing, and profiling operations in here. So going back to this example, we have a 2-axis pocketing operation programmed in here. I would go into the cut levels tab. So once I've established my location of cut geometry, the next step is the cut depth control. So the cut depth control allows you to specify the total cut depth, or how deep you want to cut the entire pocket. So the value that you're specifying here for the total cut depth is an absolute depth or absolute distance. You don't have to put in a negative sign or a positive sign. So the total depth would be determined based on where your origin is set, which could be your work zero or your WCS origin for the part being machined, and your location of cut geometry. So the total depth is just an absolute value. So in this particular example, we've set the total depth to be 1/4 of an inch. Now this can either be entered in, or you can use the option to pick the depth using the pick controls. You can pick 2 points, snap to 2 points, 1 point near the top edge, 1 point near the floor. It could be anywhere along the floor, and the system will automatically determine the height between the 2 points that you've selected. Now in the case of Visual Cam for SolidWorks or LibreCam, you could just pick the top face and the bottom face, or you could pick an edge to establish the total cut depth. Now the total depth is broken up into 2 pieces. We have rough depth and finished depth. So as you see in the graphics image over on the right, typically rough depth allows you to take deeper cuts, and for final increments down at the bottom, you can take smaller step increments. You can break it into finished depth. So rough depth plus finished depth adds to total depth. So if I set the rough depth to be 200 thousandths, you will notice that the finished depth automatically is set to 50,000. So when you add these 2 parameters, it equals the total depth. So you can use a slider control in here, and you'll notice that as you vary the slider, the finished depth parameters are varying. Now, if you're looking to program this pocket in uniform steps, so for example, in this case, the total depth is 1/4 inch, and if I'd like to cut this in 2 steps of 1/8 of an inch, you can set the total depth to be 1/4 inch. Your rough depth can be 1/4 inch, and you can split the rough depth into depth per cut by entering in a value of 1/8 of an inch. And now when I pick generate, you will notice that we end up with 2 levels, and you can go to the toolpath display in levels, which gives you the Z level display for each of your cut levels. So based on the origin, so our 0 is right here, the first cut is minus 375. Then the next cut goes down to the floor of the first step pocket, which is 1/2 inch. Now, if you'd like to cut the same pocket in variable depths, for example, you want to rough it down in steps of 100 thousandths, and then the final finish pass, you only want to take out 50 thousandths. So you can set your rough depth to be 200 thousandths, and the remainder would be your finished depth, which would be 50 thousandths. And now we can split the rough depth to 2 passes of 100 thousandths each, and the finished depth can be left at 50 thousandths, or if you wanted to go in 2 passes of 25 thousandths each, you can split the finished depth using finished depth per cut into multiple passes. So if you want to have variable depth control, like taking deeper passes on the rough depth and then finer passes on the finished depth, you can use these precise controls in here, which would allow you to control your depth per cut. So in this particular example, I've set 100 thousandths for the first 2 passes on the rough depth, and then the final 2 passes of the finished depths are set to 25 thousandths each. So this gives you the granular amount of precise control that you need for your depth per cut. And again, this is available in your 2-axis operations: facing, pocketing, profiling, in slot machining, several of these 2-axis methods which use Z-level operations. Now, while we're on this topic, I would also like to touch upon a few other things, how we can handle island tops in cut levels. So in this particular example, we have a stepped pocket. So I'm going to make a copy of this operation in here to program the stepped pocket. I will go ahead and select these regions in here. I'm going to use the chain command to select the chain of these edges, to pick the chain of the edges around the pocket and the island. And you'll notice that here in this particular example, the wall of the pocket and the island top are not at the same Z elevation or the same height. Now I'm going to go ahead and specify a tool for it. We'll specify the depth. So for the total depth, I could pick 2 points, a point near the top edge, a point near the floor of the pocket. So the total depth is 1 3/4 inches. Now I could say I want to cut in 1/2 inch steps or 3/4 inch steps for the entire pocket. I'll pick generate. So this creates equal number of passes and will ensure that your depth per cut is not larger than 1/2 inch. It'll automatically split them into equal number of passes based on the depth per cut that you put in and your total cut depth. So you will notice that we have 4 equal passes in here in this particular step. However, you will notice that the island top has not been cleared. So there's more material being left on top of the island. So let's go ahead and run a simulation to verify this in here. So I'm going to go ahead and program the facing operation first, and then we'll go ahead and simulate these operations to take a look at it. We'll do a simulate of the facing operation. We'll simulate the pocket operation in here for the first step, and then we'll simulate the pocket for the final step. So you will notice that there is more material being left on top of this island because the island top has not been cleared out. So in the cut levels tab, under the pocket operation, you can select clear island tops. When this is selected and you generate the toolpath, it'll add an additional pass to automatically clean up the top face of the island. Now the point to be noted here is when you're using clear island tops, you need to make sure the geometry that you pick for your location of the cut geometry needs to be at the top of the pocket and the top of the island. Now this would also work very well when you have multiple islands with different Z heights. The island tops could be at different heights. In this particular example, you will notice that the islands are at different heights, and selecting clear island tops will automatically be able to honor the island tops for each of the islands. So I would need to display the toolpath and then go into the Z-level display, and you'll notice that the island tops are being honored for each of the levels. So this is a easy way to program a pocket operation where you have islands without having to create multiple different operations for finishing the island tops. The next topic we will be covering here is aligning stock to part and how effectively you can align your stock geometry to part for different scenarios. So we'll go back into this example here and take a look at our stock definition. So in this particular example, the stock is defined at a height of 2.5 inches. Sorry, if I do a copy model box, this stock is, the part height is only 2.25. So we've defined the stock to be 2.5 inch in height. So if you need to face the top of the part and one of the stock faces is already planar, so you want to make sure that your bottom face of the stock is flushed with the bottom face of your part. So as you go into align and choose align stock, you can have the Z alignment set to bottom, which would ensure that the bottom face of the stock is flushed or aligned with the bottom face of your stock. So if you need to remove material 100 thousandths or 200 thousandths a quarter inch off the top face, when the top face of the stock is not even or not uniform, setting the Z alignment to bottom would be the most ideal way to program it. Now, if you have a part that requires machining from multiple orientations, let's say consider from the top and then from the bottom, you would want to consider aligning the stock in the Z to the center. So this would allow you to face the material from the top, and then you can flip the part over and then face it from the bottom, so you can remove the additional material that's being left from both top and the bottom. The XY alignment will allow you to align the stock in relation to the part in X and Y extents. So in this particular example, the stock extents and the part extents are exactly the same, which means the XY extents, the part size and the stock size are exactly equal. So selecting any of these options in the XY alignment wouldn't make a difference. So let's go back and change the stock dimensions in here. So I'm going to change the length to about 9 inches, width to a 6.25, and we'll change the height to 2.5 inches. You will now notice that the stock is larger in X and Y from the part extents. So going back to align and align stock, this would allow you to align it if you want to have it centered around so you don't leave a factory edge on all 4 sides. You could set the XY alignment to be the center, and then you can choose your Z alignment either to be at bottom if you just need to face it off from the top, or you can do center, or even at top if you want to leave more material off of the bottom. So the align part and stock geometry allows you to align the stock in relation to your part. Now you do have the option to ignore wireframe geometry in part bounds computation. So when this option is selected, it's going to ignore any wireframe geometry represents curves, which could be 2-dimensional curves or 3-dimensional curves when aligning the stock to the part. And I'm going to demonstrate this by displaying this rectangle in here that we had created earlier. So when this is drawn, and if you go into align stock, and if you select ignore wireframe, you'll notice that when the stock is being aligned to the part, the curve geometries are not accounted for when you align it. So you could say that when I choose at bottom, you will notice that it's aligning based on just the solid geometry, not looking at the curves. If you clear the checkbox to ignore wireframe, it automatically takes the curve geometries, the bounding extents of the curve geometries into account when aligning the stock to the part as well. Now let's take a look at an example on how we could do an align when working with just 2D geometries in here. So let me go in and pull in an example for that. So I have a 2D drawing in here. We'll define our stock. So I'm going to create a cylinder stock. We'll give it a height, and then we'll specify a radius. So typically, when you have a 2D drawing, the drawing by default is on your Z0 plane. So your stock, when you define your stock, it's automatically extruded in the positive Z axis. So as you go into align stock, you'd want to make sure that the ignore wireframe geometry in part bounds computation is not selected, because you're only working with 2D, so you want to have this option unchecked, and you can choose the alignment to be top, center, or bottom. So in this particular example, I'm going to set it to at bottom. So any material removal that you do will be happening from the top, and the geometry that you have drawn is at the bottom. Now you could also set it to at top depending on how we are programming it. So I will go over an example on how to program geometry using, how to program using just 2D geometries in just a moment. So for this particular case, I'm going to choose location of geometry at bottom. The reason being, I would like to face off from the top about 100 thousandths of the material. So I'm going to choose at bottom, so that my finished part thickness is going to be about 1 inch. And since I've defined the stock to be 1.1 inch, and I need to remove 100 thousandths from the top face, so aligning the stock to at bottom would be the most ideal way to go about it in this particular case. Folks, now that we have covered location of cut geometry, cut depth control, and aligning stock to part, I'm going to talk about establishing work zero, and then we'll go through a programming workflow of a complete part and how we can take all of these and tie them in together. Now consider that we've been provided a design of this 3D model. However, we've only been given a 2D drawing or a 2D representation of the part to be machined. So the CNC programmer has been only provided just a drawing of the final representation of the part, and without having to construct a 3D model, we will use the cut levels, the cut depth controls that we learned just a short while ago, and how we can apply that when programming a part by just using the 2D information. So this particular example that you're looking at here, the total thickness of the part is 1 inch, as you see it from the information in the drawing here. And it has stepped features in here, so we'll go through the process of programming it by just working off a 2D drawing. So we have the 2D drawing that's provided to us. We have established the stock by creating a cylinder stock, and the finished height of the part is going to be 1 inch. But since we would like to face the top of the blank, we will be starting with the stock that's 1.1 inch in thickness. The finished diameter of the part is 6.5 inches. So the radius would be 3.25, but I would like to have a little bit of clearance so I could go finish it, not leave a factory edge. So I'm going to start with a radius of 3.3, which is 6.6 inches in diameter. So we've established the stock definition, clicked on stock visibility. The next step is to establish our alignment. So we're going to align the stock, and I'm going to choose at bottom since I would like to remove the 100,000s from the top face of the stock. So I'm going to choose at bottom. The next thing I'm going to do is establish the work zero, and I'm going to go into work zero. This is basically work zero represents your work coordinate origin or your program zero, which means when you place the workpiece on your CNC machine tool, where would you like to touch off to establish your 000? So for this particular example, I'm going to use set to stock, highest Z for the zero face, and the center in X and Y. Since it's a circular blank, I will be setting the 0 to the top face and the center in X and Y as you notice it. Now, any operations that we program under the work zero will use the XYZ origin based off the work zero that you created. Now, if you program an operation that's above the work zero, it's going to use the location where you have your world coordinate system origin defined. So you want to make sure that you highlight the work zero and then start programming the operation. So this would automatically use the XYZ origin that you established for your work coordinate origin. So the first operation I'm going to be programming here will be a facing. And in this particular example, I'm not going to be selecting any machining region. I'll just pick a tool. And in the cut levels, I'm just going to leave it with the default settings. We'll pick generate. I'm going to select yes. And you'll notice that the system automatically takes into account the stock silhouette and creates a toolpath at the top where the stock silhouette is located. So you can see the Z display shows 0. Since the stock, we would like to take out 100,000s. For the total cut depth, I will enter the total cut depth value as 100,000s in here and generate it. So this basically takes it down to the finished face of your part in one operation. I'm going to select pause and simulate to end. In the next step, I would like to go ahead and face around this region so that the boss feature is created on the model, as you see right here. And to do that, I'm going to go back and use another facing operation. I'll make a copy of this facing operation in here. And we will now select regions. I'm going to clear these options. I'm going to pick this, the outer circle and the inner circle. Specify a tool. So I'll go with the same face mill cutter. And in the cut levels tab, now the location of cut geometry, it can be at top or it can be at bottom. So I'm going to use pick top. I know that my 0 is right over here, and we've already faced down 100,000s. So I'm going to put in my pick top for the next operation will be 100,000s below the origin, and my total depth is going to be 1/2 inch, and I'll split that into 2 levels. So if you take a look at this drawing, you'll see that the feature is 1/2 inch thick, and we've already taken out the 100,000s from the top face of the stock. So I change my pick top in the total depth, and then I'll add a cleanup pass and then generate it. So this creates the boss feature around the part. I'll pause and simulate to end. So we now have the boss feature created. In the next step, I would like to go ahead and program these holes around the feature. Hole machining, I'm going to use drilling. Select these drill points. Apply a drill filter. These are 5/8 inch holes. So it automatically excludes the larger holes even though I selected them by applying the filter. We'll pick a 5/8 inch drill bit. Again, going to the cut parameters, you have the control to specify the location of drill point. So in this particular case, I'm going to use at bottom. So I could select at bottom because the holes go all the way through on this feature, and the geometry what you have is at the bottom of the part. I'm going to specify the depth, which is going to be 1/2 inch, and also add the tooltip to drill depth. I could specify a sorting as well, and then pick generate. So this would drill the holes through to the finished depth. Now, you could either select at bottom, or you could have used pick top and specified the Z value. So it was just easier to use at bottom in this particular case. Now, the final two operations are going to be a hole pocketing for programming the inside bore, and then a final operation would be a profile to bring it to the finished size of the part. So we'll add a 2-axis hole pocketing. We'll pick this as our part region. I'm going to use a 3/4 inch end mill. In the cutting parameters, I could set the geometry at bottom. The total depth is going to be 1 inch, and I can specify the parameters for the step down, step overs, entry and exits, and then generate. And now you'll notice that since I chose at bottom, the final cut does not cut below where the bottom of the geometry is. Now, if you'd like to go past the bottom, then you would have to change your location of cut geometry to pick top, and you can specify the top to be minus 0.1 because we faced it down, and then you can specify the total depth. I could say I want to go 50 thousandths below the bottom, 1.05, and then generate. You will now notice that this would go 50 thousandths below the bottom. So if you'd like to cut past the floor, that's how you would be able to control it, by specifying the location of cut geometry to be at top and specify your total cut depth. The last operation is going to be the profile, 2-axis and profiling. I would pick this as my control geometry of the part region, select the tool, cut parameters, specify the cut level, cut depth, the total cut depth. I could leave it as 0 if I just need one pass around the bottom edge of the part and not having to specify any additional depth unless you want to have multiple cut levels. And again, if you wanted to go slightly below the origin, then you'd have to use the pick top option. So folks, you can see here, by just from a 2D drawing, you were able to program this part to achieve the exact result of the finished part that was modeled in 3D, but even though you were supplied with just like a 2D drawing. So by using the location of cut geometry, or cut depth control, you can accomplish these results without having to have a 3D part model. The last topic we're going to be covering for today is specifying cut start side in 2-axis operations. And I'm going to take an example to cover that in our Visual CAD CAM product here. Now I have an example of a 2D drawing where I would like to program some profile operations in here. I'm going to go into 2-axis profiling, and cut start side helps you determine which side you would like to place the cutter as you're programming a 2-axis profiling operation, or it could be a 2-axis chamfer or a filleting operation as well. So in this particular example, I'm going to use select curve edge regions, and I would like to profile these 2 arcs that are on the file. I've selected the 2 arcs. I'm going to specify a tool for it. And in the cut parameters, you will notice that there are several options for cut start side. So when you're working with an open curve, you would either pick cut right or cut left. So cut right represents cutting to the right side based on the direction of the curve. So in this particular example, you'll notice that when you have a region selected, a start point is displayed on the curve. So this represents this particular curve is flowing in a counterclockwise direction based on the start point. So selecting a cut start side of right will basically place your tool path or the cutter to the right side of the curve. Selecting cut start side to the left would place the cutter to the left side based on the direction of the curve. So I'm going to leave it as left and then generate this tool path. So you will notice that in this particular case, the arc, the cutter is on the left side of the arc based on the direction, since the arc direction is counterclockwise. Now, if you look over here, the arc on the top, this arc is flowing in a clockwise direction, so left would be to the left side of the arc, so you're ending up cutting on the other side. So in this case, we would have to actually program these as two separate operations unless we reverse the direction of the arcs. So in Visual CAD and Rhino, you can analyze the direction of the arcs by going into, in Visual CAD, you can go to the options, you can display the curve direction arrow in the CAD, and you'll notice that it displays the direction arrow for each of these arcs. So I would either have to split this into two different operations and pick this curve and set the cut side to right to be able to cut it in the right direction, the intended or desired direction. And for this one, I would have to drop the other region out and generate it. So you'd have to split it into two operations and select based on the direction of the arcs. Alternatively, you can, if you'd like to program both these arcs in one operation, you'd have to flip or reverse the direction of one of these arcs. So to reverse the direction, there's a couple of ways how you can do it. In Visual CAD, you can select the arc and go over to the Curve Modeling tab, and you can select Reverse, and you'll notice that it reverses the direction of the curve. And now I can go ahead and program both of these arcs in one operation to achieve the desired cut direction. Now in Rhino, you can use a command called flip to reverse the direction by going into Analyze, Direction, and Flip. Or you can even do it by creating a predefined region under the Machining Objects browser to reverse the direction. So here we looked at cut right or cut left for the cut start side under cut parameters. If you're working with a closed curve, you could select a closed geometry. In this case, I'm going to be selecting a circle. And rather than having to use cut right or cut left, selecting use outside or inside, we will override cut right or left, and we'll use the cut side to be either outside or inside, depending on the selections that you make. As you see in this particular example, we chose the cut start side to be outside when use outside or inside for closed curve is selected. Now the same goes with the example that we just programmed earlier. We had chosen use outside for the cut start side for closed curves. Now if you have a solid model and you wanted to determine the cut start side, so let's say we would like to go ahead and profile around the floor of the pocket and around the island, I could select determine using 3D model. So I'm going to use profiling. And I'll use select curve edge regions. I'll go ahead and pick these curve regions. I could be selecting either face edges or curves. And under cut parameters, I'm going to select this option called determine using 3D model. So this would automatically determine which side to place the cutter based on the solid geometry that you have in here. And then selecting generate will place the cutter on the right side of the geometry depending on to cut inside or outside when you have a solid model. So determine using 3D model will automatically determine which side based off the solid model. Now the same goes with even open curves. So in this particular example, if I have a solid model to go with it, I could use profiling, select the edges, and choose for cut parameters. I could choose determine using 3D model, and the cut start side is automatically determined based off the 3D model. Folks, with this, I would like to conclude my presentation and hand this back to Joe.
With that, do you have a quick, you have some time to show the stepovers in stepover control and 2-axis profiling real quickly?
Absolutely.
We have a few minutes.
Sure.
Thank you.
So I'm going to use the same example in here for stepover control, and I will pick maybe a smaller tool and program a profile operation. We'll define a stock so we can run a simulation in here as well. So as you notice here, we're just cutting this profile in one pass, which leaves in a material in here based on the cutter I chose. So to be able to clear up this material, you could use the stepover control and the cut parameters. You can specify a total width and a step per cut. So I'm going to use this total width of 0.2, and then I'll put in a step per cut of 0.1. So this will result in 3 passes with the stepover control set. And if you have the cut direction set to mixed, it's going to create a mixed cut direction in here. So you can control the stepover in profiling by specifying a total cut width and a step per cut. And you can also set the cut direction. So selecting mixed will alternate between climb and conventional when a stepover control is set, and also will apply for step down as well. If you choose just climb, then all stepover passes would still be performing just a climb cut. Hope this helps.
Thanks, Uday. Thank you all for attending. As I mentioned before, we will make the recording available, clean it up, and make the recording available to everyone who is registered. We have quite a few registrants here. So it looks like this is a very popular type of topic, and that's good input for us to be able to choose topics for the webinars in the future. So if you, and as always, if you have any questions, any input, any suggestions on how we can improve this process, please drop us an email. We'll be more than happy to oblige. Again, thank you all for attending, and see you next month.